Mr. B.
Wait, is it recording?
Yeah. Mr. B. Mr. B.
That was a good
one. All right. That starts our 100 days of handstands. All right, we're ready. I just have a head rush, so I'm going to start writing on the board. All right, I don't have a head rush. Thanks for the support, guys. It made a big difference. All right, so again, we're just kind of picking the next step for solving quadratics. In order to know how to do that fully, we have to deal with these situations where we're taking the square root. Okay, so this is 3.2.1, and really, this is definitely like the intro to a really larger approach to solving these kind of problems. So we're going to ease into it. It is connected to yesterday, so you can think of it this way. Before, yesterday we had two different squares. We had one that was, 8 by 8. And then we cut it in half to make it a 4 by 4 to give us our different areas, right? So the method today allows us to go the other direction. We're going to start with the total area, and from that we're going to be able to figure out the sides. Okay, so you see it's just going the other way. We have to practice this method. And then tomorrow we'll have kind of a scavenger hunt game doing that. All right? So first off, we want to isolate x. We want to know what x is. I don't care what x squared is. I want to know what x is, right? So look to see how are we going to get x isolated by itself instead of x squared. What do I need to do to get rid of the squared component there, the squared operation? What do you think? Square root. And why do you say square root?
Because it's the opposite.
Right. So squaring something and taking the square root, right? These are opposite operations, inverse operations. Okay, so we're talking about inverse operations. Really, that's what we need to do to start. I'm going to start writing black ink from now on. It's not really legible. So I'm going to take my x squared and my 64. Remember, whatever you do to one side, you do to the other side. So let's take the square root. Let's take the square root. The square and the square root are going to cancel. They cancel out. X is then equal to plus or minus. Why did I say plus or minus again? Go for it. Why did I say plus or minus? Yeah.
Because two negatives can equal positive and positive can equal negative.
Right. Because if it was just maybe beforehand, a prior lesson, root 64. Let's turn off all the lights. No, you can still see. That's fine.
Well, tell me why I can see it now. That's weird.
It is.
I can see it up.
Can everybody see?
Yes.
Okay. Too dark, so we have candlelight in math class. That sounds dangerous. Oh, no.
No, I feel attacked now. I'm gonna.
No one's attacking anybody here. No. Root 64. Root 64, bring it back. Root 64 was 8 times 8. But as Melissa pointed out, it's negative 8 times negative 8. So our answer is going to be plus or minus 8. That would be my answer. I need to account for that negative root. So let's put that here in our key ideas. You have to account for the negative root. Okay. So this is talking about doing our plus or minus. All right. So let's go ahead and do that for number 2. In fact, I'll let you guys do this one on your own just for 30 seconds. Let's go ahead and start number 2 at least. We'll keep going with these key ideas as we work through these problems. So let's see if you can find that one on your own. X squared is equal to negative 8. This one, we come into a little bit of trouble here. So don't worry, if you get in trouble, you're supposed to be in trouble. Yeah, you can ask your neighbor if you're not sure. Last 10 seconds, just getting started. If you didn't do it all, no worries.
I don't know. What does it say with the opposite inverse?
Right. I'm going to change this. Just, it's the inverse operation. We kind of use the terminology, let's take the opposite. So I was putting that in there, but that's more clear. All right, last second. Long seconds in here. All right, so who can tell me the first step? Alejandro.
Root x squared and negative 8.
Very good. Because that allows us to get rid of
This
squared value. Okay. So if this was x to the third power, and I took the third root, it would get rid of the third power and the third root. They're always connected. It's exactly the opposite. We just have to make sure we're choosing the right root. In this case, it's the second root, so we're just taking the square root. Sorry, second power, so we're taking the square root. X is equal then to plus or minus root negative 8. Now we can reduce this further, but what is one problem that we see with this now? What's one thing that we can't really have as far as in the real world? Right. We have this negative in here, right? When there's negatives under the root, we use a special type of number. You guys remember that? We're not going to go into that route, but what do we use? Imaginary numbers. Right? So the I, imaginary numbers, because you can't usually deal with this, so the sidetrack to get around it was to create imaginary numbers. Okay? We're not going to go into imaginary numbers today. What we'd say right here is that this has no real solutions. Because there's no real solutions to this. We'd have to use our imaginary numbers. And if you're curious how I would deal with this, I'd break this up to be negative 1 times 4 times 2. Right? Excuse me. This is x is equal to. Then I would go ahead and leave the plus or minus out there. But I could take the square root of negative 1 out. I could also take the square root of 4, which is 2. Deer in headlights, look. Square root of 2 is still in there, right? If you don't know how I did this, we're going to go over it right here. But this would be my imaginary answers for them. Okay, but we do not have to do imaginary numbers for this unit until I think actually next lesson 3. Right now we're only in lesson 2 of unit 3. So right here, this is where we're going to stop. We're going to label it. We're going to label and stop. Okay. We've already done a lot on imaginary numbers. We did that in the midterm quite a bit too. So I want to focus on the tools moving forward. And right away when you see there's no real solutions because there's a negative under the root, we can leave it as that. We're interested in real solutions this time. So real jokes, not imaginary friend jokes. Remember that joke?
No.
Did I kill it yet? That's a 2017 joke. I think I should leave it alone.
Oh man, that was so long ago.
The joke's been around for years. All right. Does everybody see and remember that the plus or minus, that's the main new thing. We have the plus or minus. We're going to break it down a little more when we get over here. So let's look at this. We have to reduce the root of 18. So the first step, let's take 18. And remember when we were trying to find the multiples of 18, we kind of made this little T right here. So who can give me two numbers that multiply to give me 18? Melissa? Well, how about 9 and 2? Anyone else? And we don't have to say 2 and 9. Let's say 9 and 2 and that's all. Yeah. 18 and 1. That's it. Okay. Which one of these has a perfect square? A number that we can take the square root of? Yes.
9.
So the combination I'm going to use are going to be 9 and 2. So I go back over here and I say, well, the root of 18 is equal to 9 times 2. Everybody agree with that? We just made it the multiples there. So, can I take the square root of either of those numbers? Which one can I take the square root of? 9. So I'm going to take the 9, I'm going to square root it, and when I square root 9, what do I get? 3. The root 2 is still in there. So we get, bless you, 3 times the square root of 2. 3 times the square root of 2. You see, first you do your multiples, you see which ones have a square root. You do so, rewriting it, and then you're taking out the square of 9 we can take out. We get 3. Root 2 is still stuck in there. See how we do that? Let's do another. I'd like for you to try to do 32. So the first step is to make a factor table. So let's do that. So actually, let's call it a table with multiples. We'll choose a combo with a perfect square. So those are our key ideas. That's our approach on it. So square root of 32, let's go ahead and try that. Got it? Great. All right. Once you're done, check with your neighbors, see how they're doing. If they got stuck, maybe give them a hint. If you're looking at 8 and 4, maybe think of one combination that has a slightly larger number. So 8 and 4, what else could we use that has even a larger number? There we go. Nice, Victoria. You can get to it with 8 and 4, you just have to do another step. If this method doesn't work for you, I do have a longer kind of expand method. Okay? So drop in at lunch or before school, I'll show you that. Take 10 minutes. It's just even an intermediate step to doing this, if you need that. Yeah. Yes. All right, let's bring it together. Let's come back. What are my multiples of 32? 16 and 2. I heard 8 and 4. Is there another? 32 and 1. Never choose those. Never choose 1. All right. Any others? No. Which one is going to get us the best combination for our next step? 2. Why is that the better one to choose than 8 and 4? It's a higher number. We know we can take the square root of that and end up with just a 2 on the inside. Take the square root of the 4. When we get over here, we'll still end up with the 8, which we'll have to do another break-in root. Okay, so I say we take. Get out of here. I say we take 16 times 2, and then which one of those is a perfect square? 16. So I'm going to take the 16 out. Square root of 16 is 4. Root 2. Okay. Feel okay about that? Do the multiple table, do the table with multiples, and then choose the one that meets our needs. And I say always pick the one with the larger. We pick 16 and 2 over 8 and 4 because 16 is just perfect square, and we can get more out of it that way. Okay. All right, thumbs up, sideways down so far with this stuff. So far so good. This is a review so far. All right. Like 80% of people are not answering that, but you're writing. You're holding your face up so that you don't sleep. I see a couple hands holding up. Thumbs up. Thanks, Brian. Right. Next, I want to give a key idea before we even start this number 5. We're going to isolate variable. Just like peeling an onion. What?
From the outside.
Outside. You even make a pumpkin for some reason. Wait a minute. That's an onion. Guess I don't know what an onion looks like. All right, so if you have a hard time organizing your work, some people in here make perfect lines. They're perfectly organized. They highlight, they do all this stuff. If you don't do that, you can put a line down the equal sign. This makes sure that you remember you have to do it to both sides, keeps it lined up nice and straight, and it keeps it organized for us. So I think of it this way too. It's as if X is kind of connected to all those values, all those operations. So which one of those should we break first? We're working from the outside in, where should I start? 2x squared minus 5. So I'm going to try to get rid of everything like an onion from the outside in. So what is kind of the thing that's attached to 2x squared that, let's get rid of that first. Minus 5. The minus 5 is on the outside. We're going to work our way in to isolate x. So instead of minus 5?
Plus 5.
Good. Cancels. 2x squared is equal to 200. All right, I see where this is going. We have multiplication. We have an exponent. So for this, we're doing, again, the inverse operations. Peeling from the outside in like a knife. Bless you. So what would be next then if I am working through this? Instead of 2 times x squared, yeah? 2. Perfect. X squared is equal to, what's 200 divided by 2? 100. And then we square root. You see, if we tried to square root in the very beginning, we'd have to square root everything, and then we end up with the expression underneath it. No, we don't want to do that. Again, you could always do that, but you can go any route. There's just go the path of least resistance, right? Outside in. Okay. So we're going to square root both sides, over here, over here. X is equal to, what if I just put 10? Am I right?
No.
Am I completely right?
You're 50%.
I'm 50% right. That's not a good grade. Oh. We have to remember the plus or the minus. We have to remember the plus or minus option. So x is equal to 10, x is equal to negative 10. There's 2 options. If I were to go back here and plug it in, if I do 10 squared, that's 200 minus 5, 195. If I do negative 10 squared, negative 10 times negative 10, still 100 times 2, 200 minus 5, 195. So you can see it doesn't matter which ones you have. Both of them work, but you need both. All right, final bit here. This one looks way more complicated, right? It's just a bigger onion. We start from the outside, move in. So let me put that in here, just bigger. I just wanted another chance. I might as well just make it a jack-o'-lantern. It's just a big onion. That's jack-o'-lantern. All right. And that was the most important part of the lesson, drawing orange onions. All right, let's go ahead and keep it nice and neat. Put the line down, the equal sign if you didn't, if you need to do so. Where do I start? Peeling from the outside in. What should I start with?
From the outside.
So where do I start? What would the action be? What do you write? What's next?
Don't you multiply, or like, when you multiply the 4x times 3x?
I see. You want to distribute this. But actually when we distribute, we're making it more complicated. So this has been factored, and actually it doesn't quite work with that because this is a squared value, squared expression. But if I'm working from the outside in, I'm going to go ahead and take this, instead of minus 10, Inverse operation is plus 10, plus 10. Cancel. 4x plus 3 squared is equal to 4. You see? We'll do that. And now it's gotten a little bit more simplified. It's a little easier to deal with. Okay. Anton, what's next?
I'm gonna have to phone a friend.
All right, it's fair. Who are you going to phone?
Alejandro,
Hello?
can you do a big favor for me?
Yeah, what is it, bro?
Just answer this question.
Alright, I got you. I think you divide 4 with a 4.
Oh, don't tell me.
Oh.
Oh,
Hey, Anton?
yeah, I'm here.
I think you need to tell Mr. P that you divided the 4 with the other 4. I think. I'm not 100%
Hey,
sure though.
thank you.
You need to have another person on the line to double check.
Hey, I think we
You
should
need
I'm
call
running
someone
out
else.
of minutes. I gotta hang up.
Text me, man.
See you later, love you.
Great, great.
I
I like what you said. So you want to go with that?
Yeah, you divide. I'm gonna go with what he said.
He said,
Divide 4 by the other 4. Because what you do to one side, you have to do to the other.
okay, divide 4 on both sides.
Yeah.
Okay, great. Gets rid of on this side. What's 4 divided by 4?
1.
1.
There's 1. And then what is the next step? Let's see. Who feels like volunteering for this one? Anybody?
I swear to God, you always look at me whenever you say volunteer. Like,
Anyone want to volunteer? I have a little mirror right here. All right, anybody else? You don't have to. Yeah. Reverse psychology. I'm a reverse psychologist.
Nobody else. Like,
Yeah.
aren't you supposed to square root it? But, yeah.
Excellent. Watch this. Entire. Both sides, entire thing. On the left side, it's going to cancel out. We're almost there. Square root of 1 is just 1. What else do I have to put in there?
The pluses.
Good. Plus or minus 1. Because the square root of 1, I could say, okay, negative 1 times negative 1 is 1. Positive 1 times positive 1 is 1. Say that 10 times fast. Anybody else? Who wants to do the last bit? Ooh, yawns are coming up. Let's get to classroom. Last bit. Last thing we have to do today. Anybody? Solve.
Yes, subtracting,
Solve.
Solve by?
subtracting 2.
But I was gonna actually ask if I could go to the bathroom.
Let's finish this last step of the entire lesson.
Oh my god.
That's hilarious.
This goes crazy.
All right, so we end up with negative 3. That one's too big. We get negative 3 plus or minus 1. And this is how I want you to break it down. In fact, I'm going to take this whole thing over here so that people at home can't see this, the secret in class. We're going to do a split here. Because we have the plus or the minus option, what we're going to do is split it up. I'm going to rewrite this as negative 3 plus 1 and negative 3 minus 1. I always liked when we did this. I don't know, something feels good about it. Because it's all written in one line here, and then really this is 2 different things happening. Negative 3 plus 1, negative 3 minus 1. You got it down here? So x is negative 2, x is negative 4. How many solutions we have? 2 solutions. So this is, I want you to write this as the last key idea. You could have 0, 1, or 2 solutions. And when we get to doing the quadratic, we're going to find out there's something called a discriminant, which tells you exactly how many you're going to have. So we'll go a little deeper into that, maybe in 3 weeks or so. But for now, we're going to just go ahead and put our 2 options are x is equal to negative 2, x is equal to negative 4. 2 options, donezo's. All right, how about we do a subscribe?
Oh, yeah.
Subscribe, Mathis, get it on 3. 1, 2, 3.
Subscribe, Mathis, get it!
79th wins a Kit Kat.